This is the NEET 2018 question in gravitation. The question is like this. Kinetic energy of the planets in elliptical orbit at the Sun at positions A, B, C's are where this is A, B, C's are given. AC is the major axis. SB is the line perpendicular to AC as shown. So this is AC. This is SB that he is talking about. Then how does this kinetic energies are related to each other? Where at this point its velocity is VB, VC, and at this point velocity is VA. So if I have to know kinetic energy, I know the formula for the kinetic energy as obviously kinetic energy of any body is half mv square, where m is the mass of that planet, v is the velocity at a given instant. So whenever mass is constant at all these points, so I can say as mass is same at all points, we can say kinetic energy is directly proportional to v square. So I shall know at what points of this A, B and C there is more velocity, at what point there is less velocity. For that we need to know that we can understand that this is Sun and this point is the nearest to the Sun and this point is farthest to the Sun, right? Then there is a rule that we have learned in Kepler laws, right? Kepler's second law tells you that Kepler's second law tells you that aerial vector sweeps equal area in equal intervals of time. Equal intervals of time. Let me explain what's the meaning of that, right? So I will take the same diagram. In a given time, say for example, it is moving from point C to some another point C dash, say for example. To move from C to C dash, it has taken a time t. So this, with respect to this Sun, this planet sweeps certain area of the sector. This is the aerial vector. So sweeps this much of area. Whereas when it comes to the point A, let us come to this point A here. In the same time t, it has to cover the equal area. But if you see this sector is having a longer length, but this sector is having a shorter length. So if this second area of this has to be equal to that of the area of that first sector, that is, this is the first sector, this is second sector. As this is a shorter sector, its width has to be more. So in the same time t, it moves from A to A dash, which covers more distance on the path, on this elliptical path, when compared with this distance, isn't it? Cover equal to have equal area, as this sector is, aerial vector is lengthy, its thickness is less. Look at this part. This aerial vector is shorter, so thickness is more. That means to say that the distance from A to A dash definitely greater than from C to C dash. These are the distances covered on the elliptical path in the same time t, that is as per the Kepler's second law. Displacement is more or distance is more in the same time. Thus we can say velocity from A to A dash is definitely greater than velocity from C to C dash, because velocity is defined as displacement by time. A dash by t, velocity at A, whereas at C, velocity is cc dash by t. As A dash is more than cc dash, velocity at A dash, that implies what we can say is velocity at A is definitely more than that of velocity of C. B is of course somewhere in the middle of the path. This is the shortest, this is the longest, so B is somewhere in the journey. Therefore, velocity at A is highest, at C is least. Thus, I can say velocity of A is greater than velocity of B. Velocity of B is even greater than velocity of C, because C is at a longest distance. That implies what we can say is, as per this relation, kinetic energy at the point A is greater than kinetic energy at the B, is even than kinetic energy at the point C. That's the answer for the problem. So to solve this problem, we actually go for the basics of Kepler laws, Kepler's second law particularly, which says that aerial vector sweeps equal area at equal intervals of time. Thus, when it is at farthest, its velocity is less because it has to cover less distance on the elliptical path. When it is at shortest, its distance is more because that means its velocity has to be more so that the area remains same. That's how we solve the problem. It's a simple problem, right? Conceptual problem. Thank you for watching.